Okay, the moon's origin. There is clearly more to lunar capture than simply bringing two planets close together in space. Unless the moon was slowed down somehow, it would immediately have moved away again at just the same rate at which it approached. Either there was a transfer of energy from one body to another from a distance, or else at least a third body must have been involved and taken away the energy excess. What would be the third body? Don't ask me, because I don't know. I probably would like to know. I mean, I lay awake most nights trying to imagine what that third body is, but not really. But
unless it had the ability to drive itself around and place itself, then you would not need a third body.
Oh. Yeah. Well, as it says here, there was a scientific conference back in 1994 about the origins of the moon. And the outcome of that was the least favorite classic idea going into the conference was the capture hypothesis. In its original form, the capture hypothesis held that the Earth seized a fully formed moon that came whizzing in from elsewhere in the solar system. In principle, such capture is possible but unlikely. A body passing near the Earth would probably collide with it or get a gravitational boost that would alter its orbit so much that it could never meet up with the Earth again. The chances of the orbits of the moon and the Earth being exquisitely right for capture is so minuscule that all but a few scientists had rejected the idea.
I mean, not only that, but just being in and then creating a almost perfect elliptical orbit, and then being able to eclipse the sun, and there's 108 moons between the Earth and the moon. There's 108 Earths between. Well,
yeah. So I can take here if I put in. Oh, by the way, if a very close approximation to the diameter of the moon is 2,160 miles. In fact, you can go into a lot of even textbooks, and they will surmise that they will describe the moon as being 2,160 miles, which is interesting because the moon's size, if you take the whole zodiacal belt, right, and you remember going back to the 25,920 years for the full cycle? Mm-hmm. Well, that's then divided into 12 signs. Just think of it as like a clock face with 12 hours on it. But now instead of hours, these are astronomical ages, astrological months, right? Where do we get the word month? From the moon, right? A lunar cycle. Well, if you take 25,920 years, divide it by 12...
Get the diameter.
You get the diameter of the moon.
Yeah. So it's pretty crazy.
But of course, that's just a coincidence.
Just coincidence, of course. Yeah.
Then the scientific, like again from the same conference, the second classic lunar genesis idea presented was the fission hypothesis. Right? They separate from an initial single body. The theory has a long and honorable history. George Darwin, the second son of Charles' 10 children, first proposed it. He postulated that the Earth, during a period after it formed a core, was at one time spinning extremely fast. It bulged so much at the equator that eventually a small blob spun off, becoming the moon. This scenario would account nicely for a crucial feature of the moon deduced by astronomers more than 100 years ago. Based on the satellite's orbital characteristics and size, the investigators calculated that the moon must be less dense than the Earth. So this goes back, 100 years. And there you can see that's a nice little graphic showing the tilt of the Earth's, between the Earth's and the moon's orbit. See, plane of the terrestrial orbit, which is the ecliptic. And so, the yellow is the moon's orbit, and eclipses only happen when the moon is here. Like a total solar eclipse only happens when the moon is crossing that plane at new moon, which is where the moon is between the Earth and the sun. If the moon is out here, it's not going to be an eclipse. It's going to sail by above or below. Yeah, we owe our present climate stability to an exceptional event, the presence of the moon. Yeah, these results show that the situation of the Earth is very peculiar. The common status for all terrestrial planets is to have experienced very large-scale chaotic behavior for their obliquity, which in the case of the Earth and in the absence of the moon may have prevented the appearance of evoluted forms of life. We owe our present climate stability to an exceptional event, the presence of the moon. So because we're skipping over a bunch of stuff, but the gist of it is this. We couldn't exist without the moon. First of all, like if let's say you're a planetary engineer, you're designing a planet, and you're going to seed that planet with life, but in order to do that, you have to have a watery matrix first. You introduce the precursors of life into water, but in order for that life to evolve to higher levels and eventually to have the ability to think and reason and all of this, you have to go through a long sequence of stages, right? How do you get water? How do you get, just taking the example of the Earth, how do you get life from the oceans onto land? You have to have that transitionary zone so that there can be creatures that can actually exist in both realms. And that's your intertidal zone between low tide and high tide. So it's been pretty much surmised that without the moon, there wouldn't be an intertidal zone, and without an intertidal zone, it would be very difficult to get life from the oceans onto the land.
Yeah, something couldn't evolve to. I mean, couldn't something evolve to just be able to crawl up onto land far enough to get food, and then after thousands and millions of years,
probably under exceptional circumstances. Yeah. But again, if you're the planetary engineer and you're bioengineering planet Earth, you want to come up with some way to optimize your probabilities. And the way to do that is you have that intertidal zone.
Yeah.
Okay, let's see. Final aspect here. We have shown, however, that the cold outer shell of the moon is a factor of 4 thicker than the cold outer shell of the Earth. So they're a thick, very rigid crust of the moon is essentially what the evidence shows. The other thing, the unusually high amounts of several refractory or high melting point metals, including titanium, zirconium, and yttrium. Now, so we send probes to the moon and expeditions to the moon. We gather moon rocks. We bring them back to Earth. We analyze them, and what we discover is that they're super rich in high refractory metals, which is exactly the kind of metals we use to build our spaceships to get to the moon in the first place. Turns out that some of you pick up an average moon rock and you look at the percentages of high refractory metals are 10 times or more greater than some of the greatest, like titanium, for example. Some of the richest ores of titanium on Earth have like 10% of the titanium that's in a moon rock almost picked up at random, which is another interesting thing. Why such an abundance of high refractory metals that just, only require extremely high temperatures to melt? That's why titanium and these high refractory metals are being used in high performance aerospace industry metals, so on.
From comet meteor impacts potentially, or we just don't know.
I don't know.
Yeah. Or it was built, or it's metal, or it's got some metal shell, or something. Yeah, who knows? I guess those would be the only options, though. I think, right?
Pretty much. So here, the number of craters on the moon is indeed immense. Those with diameters in excess of 1 kilometer are estimated to be more than 300,000 on its visible hemisphere, and to at least 1 million on its far side. Those smaller still number too many for any realistic estimate. There are 16 formations of the type enclosed within unbroken walls with diameters in excess of 200 kilometers, which is about 120 miles. The crater Clavius near the moon's south pole is one of them. Over 70 craters, 32 of them, of which are visible from the Earth, possess diameters between 100 and 200 kilometers. These are usually characterized by fairly smooth floors, sometimes checkered by smaller craters, such as, for instance, Clavius, which are again absent in others. The elevation of their walls, which is 1 to 3 kilometers, represents so small a fraction of their dimensions that even their rims are mostly below the horizon for an observer situated at their center. And here's just representatives of some of the cross-section. There's Tycho right there. You can see there's a bit of a central uplift, but typically examples of anomalous width depth ratios of large lunar craters. And even the large ones, they don't get any deeper.
It's
now,
crazy.
Which, again, suggests that the moon is an extraordinarily rigid object. Now, there's your classic crater, 3/5 of a mile in diameter, 600 feet deep. And if you look at that ratio right there, that's your typical ratio. So 3/5 of a mile, if I put in 5,280.
3,200 feet, 3,000 feet.
Yeah, it's about a kilometer, so about 3,280. And if I divide that by 600, so it's 5.4, about 5, just say 5, yeah. So, and if you keep going with that, I mean, if you double that size, you would double the depth, roughly, of the crater. And that's what you see on the moon until you get about 2 miles deep.
Right.
And then what happens? It doesn't, So you can see it's just how ridiculously shallow. Well, just to summarize, here are some of the lunar characteristics and anomalies. The heavily cratered surface, the extensive maria, primarily on the near side, the overall low density, the one-to-one spin-orbit coupling, the presence of mass cons associated with the maria, extremely rigid crust, non-spherical distribution of matter, large craters disproportionately shallow, very slow decay of seismic vibrations.
Which means the ringing.
The ringing.
That we've seen,
Lunar transient phenomena.
Which is like, is that the light?
Lights outgassing. So lunar transient phenomena, the nature of LTPs or lunar transient phenomena remains elusive and their origin an enigma. But let's see here. So is the moon a dead world? This was back in 1916. They've been recording weird shit going on the moon for decades and decades and decades, right? Let's see. The Lynn was a crater. The evidence that the crater Lynn was prior to the year 1866, a 6-mile crater, very deep, visible under all illuminations, and that in that year it became invisible for some months, seemingly concealed by a fog or haze that hung over it. And upon clearing up, a much smaller crater was in its place, and surrounding it a white spot like a drop of whitewash on the dark sea floor. I don't know what that was, but it was an anomaly. So here's just some quotes from the scientific literature, right? The difference between the shape of the real moon and that of an ideal plastic moon indicates that the moon has great strength. The mean density presents a number of major problems. Well, because again, a low density object should be readily compressible to a homogeneous, radially symmetrical mass that would be free to rotate around any axis. A great deficiency of mass in the uppermost layers of the lunar globe. The lunar orbiter data has produced unexpected results. And those unexpected results are that very massive objects in certain locations at the surface of the moon. Very large mass concentrations between the center of all 5 near-side maria. And a spherical nickel-iron object about 100 kilometers in diameter would be a rough equivalent. a mass of this kind would crush its way to the center of the moon. But you've got something that, whatever it is, nobody knows what it is, but an analog for something that would have the same, because when lunar orbiters were going around the moon, they were actually deflected in this orbit by some enormous mass of something under the center of each of the Maria. And
is it, tell me the Maria again, just so.
Those are the big dark.
Those are the dark spots. Okay,
yeah,
right.
Big dark spots.
Yeah. Okay, got it. Thank you.
And so what would be the equivalent? A spherical nickel iron object about 100 kilometers or 60 miles in diameter. So let's think, what in the hell? 60 miles in diameter, something sitting right under the surface? What could that be?
Right.
No one knows. But it shouldn't exist. It should, something that much greater. It'd be, imagine you put like a lead bullet onto a bowl of Jell-O. What's going to happen? It's going to sink to the bottom, isn't it? Well, these mascons should have sunk to the bottom. They should have gone all the way to the core of the moon, and then they.
If it came from a cosmic impact, you're saying it shouldn't be stuck on the shell.
Correct.
On the surface. Yeah. Interesting.
Our initial assumption of a homogeneous moon cannot be true. There's a drastic distinction between the different phases in the lunar interior. Again, every one of these are quotes. The moon is more like a hollow than a homogeneous sphere. It is as if the topography were massless and, in fact, might have enormous caves. The result will be a honeycomb of gigantic cavities. The structural strength of the rigid honeycomb crust, because that's how, in effect, the theory can be made to work, is that, remember what you said, if the could dent in, and
yeah.
I said that would be the elastic compression and decompression. Well, if you've got some rigid structure inside, right? In other words, it's not just a hollow object, but it's got this structural membrane, if you want to call it, inside the moon. That could suggest why it's not elastically responding to an impact. And then from the lunar anomalies, a peak on the crater's eastern wall was repeatedly flashing. One of them had the spectral signature of water. Multiple ones have had the spectral signature of water vapor. And if water vapor is coming from the moon's interior, this is serious. A spectrum of it showed the presence of carbon-containing gases, the emission spectrum of carbon vapor. The nature of lunar transient phenomena remains elusive in their origin, an enigma. So part of the lunar transient phenomena, flashes on the moon, outgassing that looked like it's water and carbon dioxide. Now, what do you associate water and carbon dioxide with?
Earth.
Sure.
I mean, yeah.
The biosphere. Carbon dioxide. Well, carbon dioxide is the catalyst for photosynthesis.
Yeah, life, basically.
Yeah.
I mean, yeah, life more than, yeah.
I mean, the whole thing. The Earth, the moon, us, the whole thing of life on Earth. And in fact, once you begin to understand it, you realize that the architecture of the solar system is exactly what it has to be for us to exist, right? I mean, even to the point now, the recognition that comets, which are almost certainly proving to be the major harbingers, delivery vehicles of life to Earth. Without those four big outer planets, there would be no delivery of comets to the inner solar system. It's only because those masses and distances are exactly what they need to be that you set up this kind of, some scientists have referred to it as a bucket brigade, of handing off comets, and then ultimately Jupiter hurls the comets either back out or towards the sun.
Not just the moon. Your point is kind of that it's not just the moon that's in the exact right place and doing the exact right thing and just impossibly just perfect and precise, and it's more than that. It's really the entire solar system that is. But how much of that? argues for simulation theory. Do you put any stock into simulation theory? And then I really want to get back into your punchline on this.
Well, I've kind of avoided that.
Okay.
I mean, I don't know where that takes us to. It may be just semantic, rather than, I mean, yeah, maybe we are a simulation, but what does that mean? I don't know.
I mean, does it make any sense to you when you think about all these numbers? I mean, about all these crazy coincidences. I mean, 108 suns between the Earth and the sun, 108 moons between the Earth and the moon. All of these sacred geometry numbers that you talk about. I mean, just being out there in nature, and it's just all of it. I mean, does that math that's embedded in the nature of reality at all argue for that? And
I don't know if it argues for that. It certainly does seem to argue for some kind of pattern or template of creation.